Wind energy. A presentation by Matt Beckwith, Greg Loader, and Dan Gravis. What is it? The difference between a windmill and a wind turbine is a windmill uses the wind's power to do work such as grind grain or run a saw. A turbine converts the wind energy into rotating mechanical energy used to generate power. History of wind energy. Wind has been used for energy for centuries. Ships used the wind to give them motion, and windmills have been used to grind grain for a long time. By the end of the 19th century, there were 2,500 windmills in the Netherlands. Windmills were being used to pump water in the U.S. initially. In the U.S. prior to the Rural Electrification Act, many farms were using wind turbines to generate their own electricity. How wind energy works. Power in wind is calculated using a formula. The density of the air times the diameter of a turbine squared times the velocity of the wind cubed times constant gives us the power in wind. A turbine is turned by the wind, which turns a gearbox, turns a shaft, which is connected to the mechanism needed to generate electricity. The gearbox in this instance regulates the RPMs from the turbine itself to the generator so that the generator is not overloaded. Suitable locations in Montana. Shown here is a map of wind power in Montana. The areas where the color is darker are where wind power is greater. These are theoretically optimal locations for wind turbines. Nationwide, the highest wind energy potential is in mountain passes in California, parts of Washington, Wyoming, the Great Plains, and parts of the Northeast. Solar energy creates current through heating the air, which makes the air move. If 1% of this energy is harnessed by turbines, it would be enough to suffice the world's power needs. Because of the forces needed to turn a turbine is only capable of harnessing 59% of the energy in the wind. This is optimal efficiency for a wind turbine. If we harnessed 100%, there would be no wind behind the turbine, thus no pressure change, so the turbine would not turn. The optimal height for a turbine is calculated to be 50 meters. This gives clearance for obstacles while not being too high and needing extra structure, as well as not being a greater obstacle to air traffic. Optimal locations for turbines are mountain valleys, ridges, upwind sides of mountains, seashores, and offshores. Although offshore winds are greater, the cost of these operations, as well as the ease of transport of the energy back to the mainland, is reasonably high, and this makes them not quite as optimal locations. There are many rebates and grants available for use of alternative energies. Check with your local state associations and regulations to find out more details. Shown here are just a few of the grants and rebates available in the state of Montana.